Today we are going to discuss a very interesting model, Hydroman model, which is a spatial model that integrates human and hydrological processes to study interactions between shallow water tables and land cover in flat agricultural landscapes, specifically in the Argentine Pampas. The model shows strong alignment with existing hydrological models and is validated using observed water table patterns and crop yields in the region. So, before our chat, can you please introduce yourself?
Hi there, I'm Moira Zellner. I'm happy to be here. I am a professor in the policy school at Northeastern University in Boston. I am director here of the of participatory modeling and data science at the College of Social Sciences and Humanities. I'm also co-director of the new lab for computational social sciences and digital humanities. And I also direct the urban informatics program in our school. So a lot of hats.
So, to start off, can you explain the purpose of this model and what motivated you to develop this?
Sure thing. So what motivated the development of this model was a collaboration with a group in Argentina, Miami, and in Colorado, funded by the National Science Foundation, to explore the reciprocal relationships between climate, land use change, and water level, groundwater dynamics. And the reason for it was that, in flat agricultural areas, the decisions that farmers make on what to plant and in what strategies, like whether they do like strict rotation or they adapt to water levels, can make a difference between flooding and drought. But because they're flat areas, they are very susceptible to either extreme. Now with climate change, things have become, climate has become wetter, and so there has been more of a tendency for flooding to happen. But in any case, the idea was to try to understand how then the decisions interacted with environmental dynamics to then inform decision making, and to answer questions about, is adaptation beneficial, and to what extent is it beneficial, and what kinds of adaptation also should be considered. So that was kind of like the purpose for developing that model, and in particular the idea of to keep it simple so that it was agile to explore, to do scenario exploration, but also to work in the context of participatory modeling with farmers and people working in the agricultural sector.
Now, let's discuss the development process of this model. So, what were the significant challenges in developing the model, and how did you overcome these challenges?
I think perhaps the main challenge was that navigating that tension, right, between keeping it simple but realistic. So capturing the essential complexity of the system and all of the interactions across all of these different dimensions of, water dynamics, climate, and people making decisions on land cover, and then the crop dynamics as well, right? And so that I think was I remember, in fact, I remembered earlier today, a whole conversation about how do we keep it two-dimensional only. And so then there was all of this discussion with Federico about no, but then if we think of horizons and soil horizons and how things change, I'm like, well, then we're going into 3-dimension, even if we're not representing it explicitly. And we went back and forth for a long time on that conceptualization until we realized okay, we need to do that representation of the third axis, right? And so we did it implicitly, but again, going back and forth and trying to keep it simple and economical to run, to be agile and explore all of these different scenarios. But there were many exciting things. So I don't know if that's part of the next question or not. But I think that just finding that we could create a parsimonious model, much more parsimonious model than the ones that are out there, like Mike Shee and others, that replicates the essential structure of that, or like the essential behavior of the system, even if it's not accurate, right, or not like super precise, but it just generated a similar behavior in a much more economical, transparent, and parsimonious way than established models. To us, was a huge achievement of that navigating that tension. And so we had some of the agronomists saying like, wow, like this is great because you've essentially reached the same kinds of conclusions and insights that would take much more expense and computation and in a black box for most people to deliver. So it was a challenge that totally paid off, I think.
I think you briefly mentioned about the findings of the model analysis. So, uh, could you share the main insights coming out of the model analysis in more details, and how do you think these insights influence the decision-making process of this area?
So the main insights are actually tied to management, and so like how much adaptation works or not. And so it was interesting because the representation of adaptation was a little bit of a risk aversion that can actually backfire because in trying to escape losses, farmers end up, for example, not planting.
Hmm.
But by not planting, then they don't suck up the water out of the soil, which causes worse flooding and more losses, right? So there was that interesting understanding of that dynamic of adaptation, that almost it's like not adapting was better in a way. But on the other aspect, if you're going to adapt, you really have to have the right level of information. And so having more information on the landscape and where the water levels were across the landscape rather than in just say one representative point, that was definitely better in terms of determining the strategy that was best to follow. The other interesting insight, I think, was like the use of pasture and other kinds of cover crops and the role that it might have in in controlling the levels of flooding and preventing flooding from happening. And that is a common good. That's a social good, right? And so that speaks to or suggests the need for collaboratives and cooperatives of farmers, which is something that they're used to doing. But like really thinking of like, okay, who's gonna plant the pasture to bring the levels down, and like how do we distribute it in the landscape so that it brings it down in places that can benefit us all. So that was an interesting thing of like looking at the trade-off between, of course, when you plant pasture, yes, you can put cattle in, but then there are other cash crops that you're not going to plant, right? And so you're not going to create revenue from the planting. So that's it. It just illuminated the trade-offs that farmers would have to elaborate on.
So you've made your model available via comsys.net. So how do you think about, making models available to others, and what were the main challenges in making this model available using this platform?
No, it's been super convenient to have it on the platform because it is public access, right? And so people can either because they reach our article or because they know about my work or they find it somewhere and they can download it. And in fact, I haven't checked recently, but I think it's been downloaded quite a bit. And it's been cited the paper has been cited a few times. And I think that the issue is more about getting the word out there, and especially with parsimonious models, because people tend to like go to what the industry does, what the field does, instead of looking at some of these models and how useful they can be in this context. So it's not so much about the dissemination or the making the model available that is the barrier, but like just like the field barrier in and I'm not saying that the more sophisticated models are not useful. Every kind of model has their place, and I think in the comparison across models is where we learn the most. Um, but it's about like, this could be a first approximation, a first tool that people could use to investigate questions about these reciprocal relationships, about the impacts of management which are explicitly represented, which doesn't happen in other hydrological models. And people are just still not kind of like used to that kind of modeling in this space. And so that's, I think, the main challenge. But it's great to have it in COMSES because then that makes it more available and, hopefully helps change that trend.
And finally, what's next for this model? Can you discuss any specific research questions or potential extensions you are considering for this model and work?
Yeah, so one of the things that came out of that wonderful work is like, well, first of all, I would have liked to be able to continue working with the group in Argentina, but like funding ran out, and so unfortunately that didn't pan out. But like, especially with farmers in Argentina, I still hope that can happen. But a new project is being proposed to actually adapt the model to the Turkish context. And so I'm super excited and looking forward to that opportunity. I hope it pans out and that we get the funding for it.
Thank you. Thank you very much for joining me and providing your insights about this model.
You're very welcome. Thank you for inviting me.